Today's lesson is going to cover graphing linear equations in two variables. The objectives are to determine whether a given ordered pair is a solution to an equation. We're going to find ordered pairs that are solutions of a given equation. We're going to graph linear equations in terms of two forms. One is the y-intercept form. So here we have the y-intercept b and the slope m. So this is known as the slope-intercept form. And then the standard form ax plus by equals c, where a, b, c are constant. And then we're going to see how we can solve applications involving linear equations. So to determine whether an ordered pair is a solution of an equation in two variables, we need to substitute the values of the x and y coordinates discussed earlier in the given equation. Now when we substitute the x and y coordinates and the resulting statement is true, then we can say the ordered pair x and y is a solution of or satisfy the equation. Let's look at some examples. Here we can determine whether an ordered pair is a solution. So here we have an x coordinate of 2 and a y coordinate of 2, and we have this equation. We substitute x equals 2 into this equation and y equals 2 into this equation. So here we have on the left side 2 times 2 plus 3 times 2. We check to see if that's equal to 10. That's also equal to the right side. And we see that this is a true statement. Therefore, the coordinate point 2, 2 is a solution to this linear equation that is in standard form. Let's check -3 and 4. Again, very similar process where we substitute -3 for x and 4 for y into 2x plus 3y equal 10. Evaluating, we get 2 times -3 is -6 plus 3 times 4, which is 12. -6 plus 12 equals to positive 6. So 6 does not equal 10, therefore -3 and 4 is not a solution to this equation. Finally, we have -4 and 6. Follow the similar process. X is equal to -4. Y is equal to 6. We substitute x and y into this equation, and we have the following. That on the left side, we have 2 times 4, which is -8, plus 3 times 6, which is 18. 18 minus 8 yields 10 on the left side. And we see that it's equal to 10 on the right side. Therefore, -4 and 6 is a solution to this equation. Now we're going to do a couple examples finding missing coordinates. So here the missing coordinate is the x coordinate, but we know y is equal to 11. Therefore, substituting y equal to 11 into this linear equation, by simple substitution, we have the following relationship. We subtract 3 from both sides, yields 4x on the right side, and 8 minus 3 yields 8. Dividing 4 on both sides of this equation, 8 divided by 4 yields 2, and 4x divided by 4 yields x. So x equals 2. Now we substitute it in here. In this equation, 4 times 2 is 8 plus 3 equals 11. Therefore, 2, 11 is an ordered pair. One more example. This time we have x as -2 and y is the one we want to determine. Substituting into the above equation, by substituting x for -2, we have 4 times -2 is equal to -8, and -8 plus 3 yields -5. And in this case, therefore, -2 and -5 is an ordered pair for this linear equation. That is, what we just calculated, these 2 points, -2 and -5, and 2 and 11, are points on this line. Now we're going to cover a procedure for graphing lines. So here in step 1, we choose a value for one variable. Then we calculate the value of the other variable. And then we graph the resulting ordered pair. The second step involves repeating step 1 to obtain at least 2 ordered pairs. And then the final step is to graph the ordered pairs and draw a line passing through the 2 points. And we can check the answer of our plot by checking and using a third point. So what is the general form to plot or graph straight line graphs? Well, we can consider the following forms. We can have the standard form defined as ax plus by equals c, or y equal mx plus b, which is the slope-intercept form. Here, in this case, a, b, c are constants, as well as m, the slope, and b, the slopes, are all constants. And this equation defines a straight line. And any line, any straight line, can be written in one of these forms.